Let us learn the electrokinetic properties of colloids. Electrokinetic properties. So, electrokinetic property in the sense how the colloidal particles behaves or how the colloidal particles move under electrical field. So, electrokinetic behavior or electrokinetic property of colloidal particles are described by using two terms. One is electrophoresis, and the second one is electroosmosis. Okay, let's discuss electrophoresis. Okay, electrophoresis. The migration of colloidal particles under a strong electric field is known as electrophoresis. We know colloidal particles are charged, either it is positively charged or it is negatively charged. So consider a colloid which is negatively charged. So all the colloidal particles are colloidal phases, that is dispersed phase, are negatively charged. When we apply some electric field, these colloidal particles will migrate towards the positive electrode. If it is a positively charged colloid, then the particles will migrate towards negatively charged electrode. So, the migration of the colloidal particle under electrical field is known as electrophoresis. Okay, let us study the experimental setup which is used to conduct electrophoresis of colloidal particles. To do this experiment, we need a U-tube. And this U-tube is filled with our colloid. And deionized water is filled above our colloidal particle. So this is the U-tube we used to conduct the experiment. This is the colloid. And we have to fill deionized water over our colloid. We use deionized water because there is no positive or negative ions in deionized water. So this will not, the usage of the water will not affect our experiment. That is why we used deionized water. Then we have to supply electrical field to this experiment. So we need two platinum rod. So consider this is positively charged and this is negatively charged, and we are giving some EMF to this experiment. That is, if we apply some potential difference to this experiment, what happens is, if this is a negatively charged colloid, then the colloidal level in the positive electrode region will rise. So the colloidal level in the positive electrode region will rise. This is the original level. This is the new level. This is the original colloidal level. This is the new colloidal level. Raised level. So proportionally what happens? The colloidal range in the negative electrode region will lower. So this level will be lowered to this. It is the level will be lowered, and correspondingly this level will be raised here. This is the observation. So what we can conclude from this experiment? This colloid is a negatively charged colloid. That is why colloidal level raised in the positive electrode region and decreased in the negative electrode region. Normally the EMF we have to supply to do this experiment is about 100 volt. 100 volts. This is the EMF requirement to conduct this experiment. Here I am going to mention some examples of positive and negative colloids. That is, arsenic sulfide As2S3 is a negative colloid. So consider the experiment we have done here is by using this negative colloid, that is arsenic sulfide As2S3. If we use ferric hydroxide salt FeOH thrice instead of the salt of ferric hydroxide, instead of arsenic sulfide, the rise will be here in the negative region, and the decreasing level will be here in the positive region. So that means FeOH, ferric hydroxide salt, is a positive colloid or positive salt. So electrophoresis is also known as cataphoresis. We can call electrophoresis as cataphoresis. Cataphoresis. Now, if we talk about the speed of this colloidal particle, speed of the colloidal particle can be represented by using a term which is electrophoretic, a term which is electrophoretic mobility or cataphoretic mobility. Cataphoretic mobility. So electrophoretic mobility or cataphoretic mobility is the term which is used to represent the speed of the colloidal particle under some certain potential difference. So electrophoretic or cataphoretic mobility can be defined as the speed of the colloidal particle, when the applied field strength is 1 volt per meter. Speed of the colloidal particle when the applied field strength is 1 volt per meter. Obviously, the factor which just depends on the electrophoretic mobility will be the size of the colloidal particles. So, this is all about electrophoresis. Then move on to the next one, that is electroosmosis. Okay, electroosmosis. Okay, let's start with the difference between the electroosmosis and electrophoresis. So what happens here in electrophoresis is the colloidal particles moves along with the medium, that is medium and phase. Both are moving towards the electrode which is oppositively charged with respect to the dispersed phase. But in the case of electroosmosis, the movement of the colloidal particles, that is movement of the dispersed phase, is prevented. So we can define electroosmosis as the movement of the dispersed medium under the influence of an electric field when the movement of the colloidal particles are prevented. Movement of the dispersed particles are prevented. So, electroosmosis is the movement of the dispersed medium under the influence of an electric field when the movement of the dispersed particles are prevented. Okay, let us learn about the experimental setup which is used to conduct the electroosmosis. This is a simple apparatus which is connected to two glass tubes, both sides, and this apparatus is divided into three portions. We can call it as section A, B, and C. Section A and B are filled with water. So this tube, I'm going to name it as T, and this is as T dash. So both T and T dash are also filled with water. A, T. The B is also filled with water. This tube T dash is also, water level is in T dash also. And our colloidal particle is inserted into, or colloidal particle is filled in the section C. Okay, colloidal particles filled here. Then these two sections A and B are connected to electric field. Positive and negative electric field. And one more thing is there. The walls of these two walls are constructed by using dialyzing membranes. So it is clear that these two membranes will transfer the particles within this medium selectively. That is, the colloidal particles will not be moved out from the section C. So when electric field is applied to this system, applied to this apparatus, what happens is, if consider this colloidal particles negatively charged colloid. This is made with, this colloid is negatively charged. That is, dispersed phase is having a charge which is negative charge. So when electric field is applied to this, what happens? The dispersion medium moves towards the oppositively charged region. This dispersion medium, if dispersed phase is negatively charged, certainly the dispersion medium will be in positive. Dispersion medium is positively charged. So, if electric field is applied to this, the medium, that is positively charged medium, will move towards negatively charged region. That is, the medium will move towards negatively charged region. So the water level, if the solvent is moved towards this region, what happens? The level in this tube T dash will be raised. The level of the T dash will be, water level in the T dash will be raised. So from this we can identify that the colloidal particle is negatively charged because water level in the negative region is raised. That means the medium which is coming to this region is positively charged. Obviously the phase will have oppositely charged with respect to the medium. So that is negatively charged. So what happens if the colloidal particle is positively charged? So if the colloidal particles are positively charged, medium will be negative in charge. So when electric field applied to this negatively charged medium will move towards the positively charged electrode, positively charged region. So water level in the T tube, water level in the tube T will be raised up, will be raised. So from that we can identify that the medium or the dispersion medium of the colloid is negatively charged since it is positively charged. So the colloidal particles will be positively charged. So that means the colloid is a positive colloid. So this is how electroosmosis helps us to identify the type of the colloid or help us to identify the nature of the colloid. So from this information we can say electroosmosis is the reverse process of electrophoresis. It is the reverse process of electrophoresis. Okay, this is all about electroosmosis. And these are the two techniques, electroosmosis and electrophoresis, which is used to identify the electrokinetic behavior of colloidal particle.